In today's lesson on Chapter 6, we are actually going to be working backwards from what we were doing last class. Last class, I gave you the x value, and then you converted it to a z-score, and then you turned it into a percentage. Today, I'm going to be giving you percentages, and you're going to be finding the specific x values or data values that correspond to those. So let's look at the general steps for finding data values from percentages. The first suggestion is always to draw your normal model. Draw a picture, figure out what percentage we're looking at. Are we shading to the right? Are we shading to the left? Where are we at? Then you need to make sure that you find your percentage or your percentile on your blue sheet. Now, when we did this, we were looking up z-scores on the outside and the percentiles were on the inside. So when you're finding the percentile on your blue sheet, you are looking in the middle. Now, there's going to be many times where there isn't the exact answer that matches, so you're just simply looking for the decimal that is the absolute closest to the percentage that you need. Then, once you found the percentage, follow left and up to find that corresponding z-score. Then, once you're done, you're going to plug the z-score in, so you'll know that guy. You'll automatically know the mean, and this is another name for x-bar, and you will automatically know the standard deviation, or another name for s. This time in your work, you're going to be working backwards to find your x value. That's going to be your unknown. And we did an example like that in the last lesson, so it wasn't very difficult to work backwards. So just remember, we're focusing on drawing our normal model. If you're looking up percentages on the blue sheet, let me remind you of something else. Okay, you must always be shaded left in order to use your blue sheet. So some of your problems will be shaded left, some of them will not. So you need to deal with what happens if I need to shade left. So let's look at some examples. The circumference of oranges from a certain tree have an approximately normal distribution, that's important, with a mean of 20 centimeters and a standard deviation of 4 centimeters. Describe the circumference. Notice it doesn't say find the percentage. Describe the circumference of the largest 10% of oranges. So here's our spectrum and our curve. Now keep in mind, this is our x-axis. Now this x-axis represents the circumference of the oranges. So obviously your largest 10% is going to be somewhere over on the right side. So we normally think of having 0 in the middle. So 10% is not a lot. So somewhere over here, I'm just going to make a mark. That's going to be the z-score that I'm eventually trying to find. And the largest 10% would be shading over here to the right, as far as I can go. Well, so let's make some notes. This is 10%. Well, remember, the one thing I said that was extremely important was this only works when you're shading to the left. So I need to be shading all of this to be able to use the blue sheet. Well, what percentage is that? Well, that should be pretty easy to figure out because we know that the entire graph is 100%. So if the red portion is 10%, then that makes the blue portion 90%. So we're not really using 10% anymore. Our focus is 90%. So 90% is our percentage. Here's the problem. The blue sheet spits out decimals. It doesn't ever spit out whole percentages, it spits out decimals. So the first thing we want to do is turn this into a decimal. So you can either move your decimal 2 places to the left or divide by 100 and you get 0.90. So we are looking on our blue sheet. You're going to pick up your blue sheet. We're going to go, because this z-score we know is a positive z-score, you're going to go to the positive side of the blue sheet and you're going to start looking in the middle of that blue sheet. And you're trying to find the closest number you can find to 0.90. So you've probably noticed by now that there is no 0.90. So you're looking for the closest number to it. Well, the closest thing I find is 0.8997. That's only, if you think about your decimals, you have tenths, hundredths, thousands, 10,000ths. That's only 3/10,000ths away. That is definitely the closest you're going to get. So then, as I said, you go left to find your first two digits, which I get a z-score starting with 1.2. Then you went up from that value to find your last decimal, and I get 8. So that's how you find your z-score. Now, we're going to plug it into our little formula. So remember, your formula is z equals x minus x bar divided by s. So z is 1.28 equals, we won't know x on these problems, minus x bar is your mean of 20, divided by s is your standard deviation of 4. And now we have to work backwards. So just like last class, the first thing we want to do is get rid of that division. So we're going to change it to multiplying, and we're going to multiply both sides by 4 to cancel. 4 times 1.28 is 5.12 equals x minus 20. We need to add 20 to both sides to cancel out that 20. And that leaves us with x equals 25.12 centimeters. And so the largest 10% of oranges are greater than that amount. That's the cutoff. They are greater than that amount. So that is how you do a working backwards problem. Let's look at another one. Describe the circumference of the smallest 4% of oranges. So again, if we're thinking this is a x-axis scale with 0 in the middle, the left side is always the smaller side. So somewhere over here, there is a z-score, and the smallest would be shading to the left. So this part right here is 4%. Well, that's a good thing. We like shading to the left because shading to the left is what the blue sheet does. So we're going to take that 4%, and that's the number we're working with. So the first thing we need to do, divide by 100, change it to a decimal. If you divide or move your decimal, you should end up with 0.04. And so then you go to your blue sheet, and because we know we're on the left of 0, you know you're looking at the negative side. And so again, we start looking, and there isn't an exact 0.04, but I do see a 0.0401. Hopefully you see that number. And so if we go to the one side, we get a z-score that starts with negative 1.7. And then if you go up from that 0.0401, it ends in a 5. So now that we have our z-score, we're going to do our math. So our z-score is negative 1.75. We don't know x. The mean is still 20, and the standard deviation is still 4. So we're going to solve exactly the way we solved the other one. First, we're going to multiply by 4. That gets rid of the 4's. Negative 1.75 times 4, I got negative 7 equals x minus 20. Then we have to add 20 to both sides. Negative 7 plus 20 leaves me with x equals 13 centimeters. So this time, the smallest 4% of oranges has to be, because it has to be lower, it has to be less than 13 centimeters. So let's try the third type of working backwards problem. So we've done a largest, a greater than, a shading to the right problem. We've done a smallest, a less than, a shading to the left problem. Now we're going to look at describing the circumference of the middle 40%. This is tricky simply because you have to think about what percentage. So, here's our x-axis with our curve, zeros in the middle. We want the middle 20%. Now, here's one nice thing about this. Because it's the dead center, we know it's even on both sides. So we know whatever z-score is over here, the exact same z-score is over here, but negative. That's a good thing for us. So we're going to draw two boundaries, and we are shading between them. So here's the problem. The blue sheet only shades to the left, and it has to shade all the way to the left. So I'm going to show you some tricks. The first thing I know is I'm going to divide this in half. Here's why. I know all of this is already 50%. What is this part right here? Well, hopefully you're thinking middle 40% would mean that this part is 20%. And 50% plus 20% tells us, and we're finding this z-score, you could have done the other one, I'm just doing the positive one, tells us that we're looking for a 70% on our blue sheet. Put them together, you get 70. That changes to a decimal of 0.70. Now this is the positive one we're finding, so go to your positive side and start looking for 0.70. And I'm seeing, well, I see two options. I see one above and one below. I see a 0.6985 and a 0.7019. Well, which one's closer? Well, the 0.7019 is 19 above. The 0.6985 is 15 below. So 15 below is closer. So we're focused on the 0.6985, which if we go left, starts off our z-score with a 0.5, and if we go up, it ended in a 2. So the thing is, this one's positive 0.52, and this one's negative 0.52. So what you simply have to do is you have to convert them both into x values. So let's start with the negative one. Negative 0.52 equals, we don't know x, our mean is still 20, our standard deviation is still 4. Same as before, we're still multiplying by 4. Negative 0.52 times 4 gives me negative 2.08 equals x minus 20. Add 20. Negative 2.08 plus 20 gives me 17.92 centimeters. So then we have the 0.52. It also equals x minus 20 divided by 4. We are also going to multiply by 4 on both sides of this one to cancel. The only difference here is it comes out to be a positive 2.08. Now is when we're going to get a different answer, because we're going to add 20 to 2.08 and we get 22.08 centimeters. So the answer to our question, describe the circumference of the middle 40% of oranges, they are between 17.92 centimeters and 22.08 centimeters. And so those are your basic 3 types of working backwards problems. Now, the final example that we're going to look at, we're going to put together both days' work, because you do need to stop and look at problems because your test is going to be mixed together. You have to look and say, am I finding a percent or am I finding an X value? So let's take a look at our last example with several. Suppose a normal model describes the fuel efficiency of cars currently registered in your state. We got the normal model, we're good. It says the mean is 24 miles per gallon. The standard deviation is 6 miles per gallon. So when you tackle these, you look at the question and see what it's wanting you to find. It says what percent. So this is asking for a percent. This is a working forwards. So we have X, we eventually want to find the percent. So with X, we convert it to a Z-score. So we're trying to find what percent of all cars get less than 15 miles per gallon. So let's find our Z-score. Our X is 15 minus our mean is 24 divided by our standard deviation is 6. Subtract, divide by 6, round if necessary, but I get a nice pretty negative 1.5. Now, if you want a second decimal, that would be a 0. So, we know, I'm just drawing a rough sketch, nothing fancy, zeros in the middle, we're over here. This problem was a less than problem, so we're shading to the left. So, this is a good problem, left is good. Go to your blue sheet. Now we're back on the outside. Z-score is outside. That's what we have as a Z-score. So go to your negative side. Go down to negative 1.5 and over to the very first slot. And you should get 0.0668, which, if you move your decimal, gives you 6.68%. That problem's done. Next question. What percent, so again a percent, of all cars get between 20 and 30? This is a between problem. We know what to do here. We know we're going to be subtracting. So we have 2 Z-scores to do. I always stick with the high one first. So let's start with 30 minus, the mean is still 24, divided by standard deviation is still 6. If you subtract and divide, I end up with a nice even 1. So then we go Z-score. We have a 20 minus a 24 divided by 6. And we end up with, again, subtract and divide. I get negative 0. And we need 2 decimals, so it rounds appropriately to 6.7. Now, since we know this is a between problem, if you don't want to draw your picture and you want to go straight to it, that's fine. I'm just going to draw real quick. 0's here, 1's over here, negative 0.67's over here. We're going in between them. So, go for the number 1, go to your positive side, go down to 1.0, and then go over to 0, and I get 0.8413. Then flip over to the negative side, go down to negative 0.6, go over to the 7 slot, and I get 0.2514. And we are subtracting. And I get 0.5899, which changes to 58.99%. And then finally, our last kind of what percent problem of cars get more than 40. So Z-score, 40 is X, minus a mean of 24, divided by a standard deviation of 6. Subtract, divide, round appropriately to 2 decimals, I get 2.67. Well, we know this is positive, over here somewhere, 2.67. This is a more than, which means we're shading to the right, which means whatever we get off the blue sheet, we know we need to do 1 minus. To the right is always 1 minus. So go down, or go to the positive side, down to 2.6, over to the 7 slot, I get 0.9962, which when I subtract, I end up with 0.0038. Move the decimal is 0.38%. So go ahead and turn the page. Now we are going to describe the fuel efficiency of the worst 20% of cars. So now we're finding the fuel efficiency, and I'm giving you a percentage. So that should tell you that we are working backwards. So we're looking at, here's our X scale, zeros in the middle. We want the worst 20%. Worst is the lowest. Lowest is the left somewhere. So we know that this percentage right here is 20%. And that is on the left, and left is good. So we're ready to simply change 20% into a decimal. And that decimal is 0.20. So now we're ready to convert it to a z-score. So go to your negative side and start looking for 0.20. And I see one that's pretty close. I see a 0.2005. And so that's the one I'm going to go with. So that, if I go over to the one side, starts me off with a z-score of negative 0.8. And then if I go up, it goes up to the 4 slot. And so now we just have to do our math. Let's work backwards. So negative 0.84 equals, we don't know x this time. The mean is still 24, and the standard deviation is still 6. Multiply both sides by 6. 6 times 0.84 is negative 5.04 equals x minus 24. I'm going to add, there we go, 24 to both sides. Negative 5.04 plus 24 tells me that I end up with 18.96 miles per gallon. But we want the worst, so that means the worst is always less than that cutoff. So let's have you try just one on your own, because you haven't done a working backwards. So pause the video, try this one, and we'll see how you did by yourself. All right, so describe the gas mileage of the most efficient 5%. So most efficient should have been screaming to you highest. So we're over here somewhere with our z-score. And highest, most efficient means I'm shading to the right. So this is 5%. Well, we don't like right problems. We only like left problems. So all of this over here is what percent? Well, 100 minus 5 leaves me with 95%. So you should be taking 95%, moving that decimal to 0.95. And then hopefully you looked on the right side of your blue sheet, the positive side, and the closest thing I am seeing to 0.95. Well, hopefully this is a good one to talk about, because I see a 0.9495 and a 0.9505. The 9505 is 05 above, and the 9495 is 5 below. This is a great example of what happens if there's two that are the same distance. Can I pick which one I want? And the answer is no. The answer is we're going to split them in the middle. Well, what do they both start with? if we go over, they both start with a z-score of 1.6. If I go up, I have a 4 and a 5. So in between 0.04 and 0.05 is 0.04 and a half, or 4.5. So this is a tricky one. It was right in the middle. So you have to find the middle of those two decimals, and it's simply a 5. It's going to be an extra 5 on the end. So let's do our math. All right, so we have positive 1.645 equals x minus 24 divided by 6. And so we're going to multiply both sides by 6. 6 times 1.645, I get 9.87 equals x minus 24. Then I have to add 24 to both sides. And I get x equals 33.87 miles per gallon. Well, because this was a most efficient, it means that we are greater than that number. All right, so let's look at some problems that we haven't really discussed yet. These are some of your specialty problems. What gas mileage represents the third quartile? Third quartile is Q3. Well, here's some nice things. Q3 is always 0.75. Okay? Q1, if they asked for the first quartile, is always 0.25. And so, well, actually, let's back up so I don't confuse you guys. The third quartile is always 75%, which is always in decimal form 0.75. So you need to go to your positive side of your blue sheet, and you need to find 0.75, and I find 0.74, looks like 86 is the closest one, which is over to a z-score of 0.6 and then up to the 7 slot. So let me tell you some tricks. We all like tricks. Third quartile, if you want to save yourself this looking up process, the third quartile, no matter what the problem, because third quartile is always 75%, it will always be a z-score of 0.67. Always. Never changing. So if that helps you and you want to memorize third quartile is 0.67, I'm okay with that. But now we got to turn this z-score into an x value. So 0.67 equals, we don't know x, minus 24 divided by 6. Multiply both sides by 6. 6 times 0.67 is 4.02 equals x minus 24. Add 24 to both sides. And I get a third quartile of 28, that's an 8.02 miles per gallon. So here's how this ties in with the next question. Find the IQR of all cars. Well, if you remember, IQR is always Q3 minus Q1. Well, we just found Q3. Well, we still have to find Q1. Well, I just got through saying Q1 is always 25%. So if we treat it the same way we treated Q3, that's a 0.25. This one you're going to be looking up on your negative side because it's less than the halfway point. So if you look it up on the negative side, the closest thing to it is 0.2514. 0.2514 goes over to a z-score of negative 0.6, and up to a 7. Do you notice something? Hopefully you're thinking they're the same, but one's positive and one's negative. That's because 75 and 25 are mirror images of each other. So now you have some shortcuts. Third quartile, 0.67. First quartile, negative 0.67. So let's do the working backwards part. Negative 0.67 equals x minus 24 divided by 6. Still multiplying. The only difference here is the negative, so I'm just going to have a negative 4.02 equals x minus 24. I'm still adding 24 to both sides. We will get a different answer though. Negative 4.02 plus 24 gives me 19.98 miles per gallon. So now all we have to do is the actual math that this question asked. Q3 was the 28.02 from above minus Q1 is the 19.98 that I just found. My 8s don't write very well. There we go. And so the IQR for this whole problem, if you subtract those two numbers, is 8.04 miles per gallon. Alrighty, final question of this video. What gas mileage would you consider unusual and why? If you remember, the one thing we talked about with z-scores is the further away from 0, the more unusual. In our class, I have a magic cutoff. Unusual is always higher than 2 standard deviations. And remember, standard deviations are another name for a z-score. So higher than 2 z-scores is unusual. So all we have to do is take 2 and translate it back to an x value. So 2 is my z-score. Don't know x. The mean is 24. The standard deviation is 6. Multiply both sides by 6. 6 times 2 is 12 equals x minus 24. Add 24 to both sides. So for us, unusual is 12 plus 24 is 36 miles per gallon. Or we know because it's higher than, we're going to say greater than 36 miles per gallon. And it's unusual because it's 2 standard deviations away. Remember, it's outside of those really high cutoffs. And that's the end of the working backwards lesson, and we will see you in class.